We started discussion on quantifiers in our last class. We were discussing how we can quantify our predicates, our propositional function. कि एक predicate कितनी values के लिए true है या false है. It could be true for everything or it could be true for something. या हम इस तरह भी कह सकते हैं कि it is true for, it is false for everything or it is false for something. So we start our discussion with predicate or propositional function. When we give input to some predicate, it becomes a proposition. We can say for this particular input, this predicate is true or false. So for how many inputs it's true, and for how many inputs it could be false. If it is true for every input, हम जो भी input दें, इनपुट हम अपने जो यूनिवर्स ऑफ डिस्कोर्स है उसकी इनपुट देते हैं, जो हमारा इनपुट साइज है जिसके बारे में हम बात कर रहे हैं, तो दैट इज कॉल्ड यूनिवर्स ऑफ डिस्कोर्स. सो आवर इनपुट आर एलिमेंट्स ऑफ आवर यूनिवर्स ऑफ डिस्कोर्स. हमारे इनपुट सेट में से जो एलिमेंट्स हैं, अगर तो हमारे प्रेडिकेट हर एक वैल्यू के लिए ट्रू है, फॉर ईच एंड एवरी सिंगल वैल्यू इट इज गोइंग टू बी ट्रू, then we call it universal quantifier. क्या हमारी statement universally true है या universally false है, either true or false. So we express this thing as universal quantifier. और अगर हमारी statement किसी एक particular value के लिए true है या कुछ particular values के लिए true है, so it means there exists something for which it is true. So we call it is existential quantifier. Existential quantification, when it is true for at least one value, and it could be more than one, it could be even all values. So when it is true for some values, okay, there exists something for which our predicate is true, then it's called existential quantifier. Yeah, if there is something for which our predicate is false, so then it's existential quantification. हम क्वांटिफाई करें उसको, या तो यूनिवर्सली क्वांटिफाई करें, या वी आर जस्ट टेलिंग इट कि देयर एग्जिस्ट समथिंग फॉर व्हिच इट इज ट्रू और फॉल्स. सो वी हैव यूनिवर्सल क्वांटिफायर. इसका जो मैथमेटिकल सिंबल है, इट्स लाइक अपसाइड डाउन ए स्टैंड फॉर ऑल. सो फॉर ऑल एक्स, एक्स इज आवर इनपुट, एक्स इज आवर element from our universe of discourse, from our input set, from our domain set. X is some element. When our statement P of X, our predicate, it is true for X. For X किस तरह का है? It's all values, all possible values of X. When predicate is true for all values of X, then we call it universal quantification. For all X, P of X holds. For all X, P of X is true. And then we said कि जो universal quantifier है, ये conjunction होती है, ये and operation होता है. So this is and operator between among all the inputs, all possible inputs, कि आपका predicate first value के लिए भी true है, second, third value के लिए भी true है, and so on. For all values our predicate is true. For all values our predicate is true. So this is universal quantification is and operator. And operator, and तभी वन होता है जब हर एक वैल्यू ट्रू हो. अगर कोई एक वैल्यू भी फॉल्स हो गई, our whole expression becomes false. So universal quantification is conjunction, it's and operator. And then we did a number of examples for quantifier. There was existential quantifier. There exists something for which P of X is true. So symbol of existential quantifier is flipped E. E को हमने flip करके लिखा है. E stand for exist. So there exists some X, there exists some value X for which P of X is true. There exists X, P of X is true. And then we said कि जो existential quantifier है, it is a disjunction. It's an or operator. So अगर किसी एक वैल्यू के लिए भी हमारा एक्सप्रेशन, हमारा प्रेडिकेट ट्रू हो गया, the whole expression becomes true. So existential quantifier, if there exists something for which our predicate is true. When these quantifiers are true, when these quantifiers are going to be false. For all x, p of x, universal quantifier. So obviously it is true when it is true for each and every value of x. ये false कब होगा? It's going to be false, it's going to be negated when we can find at least one exception. अगर कम से कम एक वैल्यू के लिए ये दुरुस्त ना हो, then it is, we cannot say कि for all x, p of x, क्योंकि there is something for which it is true. It could be one value, it could be two value, it could be many values for which it is not true. So for all x, p of x, its negation कब होती है, ये false कब होता है, when there is some x for which p of x is false. On the other hand, existential quantifier, when it is true, when there exists something for which it is true, and when it is going to be false, if it is not true for any value, for all values of x, our predicate p of x is false. So p of x is false for each and every value of x. Then we cannot say that there exists some value of x for which p of x is true, because it is false for every value of x. So this statement becomes false. So please notice here, जब हम universal quantifier की बात करें, for all x, p of x is true. जब इसकी negation हो रही है, when it is going to be false, so we just need to find there is something, some x for which p of x is false. In other words, when universal quantifier is false, so it means we are going to have an existential quantifier. There is an x for which p of x is false. So an existential quantifier है कि there exists some x such that negation of px becomes false. So p of x bar negation of px, p of x is false. So when for universal quantifier की negation में हमारे पास existential quantifier आ रहा है with negation of predicate. इसी तरह जब हम existential quantifier को देखते हैं, there exists x, p of x, इसकी जब negation हो रही है when it is going to be false, तो क्या हो रहा है, p of x is false for every x. So over here there is a universal quantifier. For all x, p of x is going to be false. For all x, negation of p of x. For all x, p of x is false. So we have a universal quantifier in the negation of existential quantifier. So just a rule of thumb, जब universal quantifier की negation करते हैं, universal quantifier converts into existential quantifier and p of x predicate की negation. Existential quantifier की negation जब होती है, so existential quantifier is changed into universal quantifier with negation of our predicate p of x bar. We did some examples, and then if we are given an English statement, a simple statement, how to express it mathematically. So we did a number of examples in last class. Negation, इसके भी हमने बात की कि for all x, p of x universal quantifier है. इसकी negation कब होगी, ये false कब होगा, if there exists some x जिसके लिए p of x false है. So there exists x such that negation of p of x. तो ये universal quantifier की negation हो जाएगी. Existential quantifier है हमारे पास, there exists x, p of x, इसकी negation कब होगी, when p of x is not true for each and every value of x. So for all x, p of x is not true. किसी भी x के लिए p of x true नहीं है. So we cannot find even a single x for which p of x is going to be true. So existential quantifier की negation for all x, not p of x. And then we proved this also using De Morgan's law. So always remember how to prove this using De Morgan's law. And negation of truth values and quantifier negation की truth values. These are opposite to what we just saw कि quantifier की truth values क्या है. And then we did some other examples. For example, there is an honest politician. So इसकी negation क्या होगी? All politicians are dishonest. Okay, we cannot find even a single politician who is honest. So all politicians are dishonest, which is actually true. All Americans eat cheeseburgers. So its negation would be there is some American, at least one American, who doesn't eat cheeseburgers. So ये चीज the exception इस statement की negation कर रहा है, which says all Americans eat cheeseburger. So there is an American who does not eat cheeseburger. So इसको keep in mind जब हम इसको mathematical notation में लिखते हैं, we have to define our universe of discourse, our input size, our domain set. So over here, all Americans की बात हो रही है. So X is an American, E of X eat cheeseburger. So all Americans eat cheeseburger. For all X, E of X holds that all Americans X eat cheeseburger. Negation क्या होगी? There is some American, there is some X for which E of X is false. There is some X such that X does not eat cheeseburger. So इसकी negation होगी. And then we did some other example mathematical expressions. So negation, universal quantifier is changed into existential quantifier. Existential quantifier changes into universal quantifier. और जो अंदर वाली statement है, आपका predicate है, उसकी negation हो जाएगी. So today we are going to discuss about multiple quantifiers. एक statement में जब हमारे पास एक से ज़्यादा quantifiers आ जाते हैं, so we can call it mixing quantifiers, or we can also call it nested quantifiers. Nested quantifiers. Actually, this is some concept similar to nested loops. जो हम for loops nested लगाते हैं, it is similar concept to that. Nested quantifiers या mixing quantifiers या multiple quantifiers. So एक statement में when we have to use more than one quantifiers, so it is possible if we are discussing about more than two kind of elements. हमारी statement इस तरह है जिसमें दो से ज़्यादा subjects involve हो रहे हैं, दो से ज़्यादा actors involve हो रहे हैं, दो से ज़्यादा हमारे पास ऐसे elements involve हो रहे हैं about which we are talking about. So suppose if we have X and Y, these are two kind of people, two kind of objects, two kind of elements we are talking about, and then our predicate deals with both of them, like X on Y, या Y X on X. It depends how you define your predicate. So we can use both quantifiers. So statement could be for all X, there is some Y such that P of XY holds. It could be for all X, for all Y, P of XY. Yeah, there exists some X for all X, Y, P of XY holds. Yeah, there exists X, there exists Y, P of XY. So हमारे पास दो तरह की quantifier हैं, दो ही अगर हमारे पास elements हैं, there are four possibilities जिनके जरिए हम नेस्ट कर सकते हैं क्वांटिफायर्स को, जिनके जरिए हम मिक्स कर सकते हैं क्वांटिफायर्स को. Before looking at some example, just be careful कि जब आप मैथमेटिकल एक्सप्रेशन डिफाइन करते हैं, you have to be careful कि आप क्वांटिफायर्स का ऑर्डर किस तरह रख रहे हैं. For all X there exists Y होगा या there exists Y for all X होगा. So both may mean different thing. अगर एक ही तरह की क्वांटिफायर है for all और for all है, उसमें तो आप इंटरचेंज करने की फर्क नहीं पड़ता, या there exists X, there exists Y, उनको आपस में इंटरचेंज करने की फर्क नहीं पड़ता. लेकिन अगर यूनिवर्सल क्वांटिफायर है और एग्जिस्टेंशियल क्वांटिफायर है, उनको आपस में इंटरचेंज करते हुए वी हैव टू बी वेरी केयरफुल, क्योंकि पूरी स्टेटमेंट का मीनिंग बिल्कुल ही चेंज हो सकता है. आइए देखते हैं कुछ एग्जांपल्स. So we have this example: for all X, there exists Y such that X loves Y. Loves X, Y, ये हमारा predicate है. So X loves Y. For all X, जितने भी लोग हैं, तमाम के लिए X loves. There is someone Y to whom they love. So everybody loves somebody. In certain, in simple expression, we can say everybody loves somebody. लेकिन अगर हम क्वांटिफायर्स का रोल इनको आगे पीछे कर दें, there is someone for all X loves XY. So there is someone who's loved by everyone. Everyone loves someone. and there is someone who is loved by everyone. So इन दोनों का meaning totally change हो जाता है. We can maybe form an other example which may help to see how things are totally changed if we do not respect the order of quantifiers. For example, we say nationality X is national of Y. National. So nationality की बात है, let's call X Y. So X is a person, Y is a country, just like this. So we define X is a person, X is a person, and Y is a country. Y is a country. So national XY means X is national of Y. Mr. X is national of country Y. Okay. Like Mr. Ali is national of Pakistan. So national Ali, comma Pakistan. Ali is national of some certain country. So अगर हम यहाँ पे quantifiers use करें, we can give two statements and then we look at their meanings. So for all X, everyone, there exists some country Y such that so national XY. Right now, national XY. Yeah. So for all X, for everyone, there is some country such that X is national of that country. के हर एक शख्स की कोई ना कोई nationality होती है. They belong to some country. Everyone belongs to some country, just like this. Fine. Okay. अगर हम quantifiers का order आगे पीछे कर रहे हैं, फिर क्या होगा? So this will become there is some country, everybody belongs to that country. If we are going to change the order of quantifiers, then let's see what happens. So there exists Y is from शुरू में ले आते हैं control X over here. Yeah, there is some country such that everybody is national of this country. So now this statement means there is a country such that everybody is national of this country. Everybody belongs to this country. Belongs to this country. So for some country, everybody is national of this thing. So हमने just quantifiers को आगे पीछे किया, उनका order change कर दिया. For all X there exists Y. अब हमने क्या कर दिया? There exists Y for all X. Meaning of statement is totally changed. Meaning of statement completely change हो जाता है. So we have to be very careful about the order of quantifiers. अगर हमारे पास एक ही तरह के quantifiers हैं, for example, we have similar quantifier, there exists X, there exists Y, P of X, Y, then that's fine. We can interchange the order, we can switch the order of quantifiers. There exists Y, there exists X, P of X, Y. या इसी तरह अगर for all X, for all Y है, तो we can say for all Y, for all X. अगर similar quantifiers हैं, in that case, it will not affect the meaning of the statement. लेकिन अगर different quantifiers हैं, उनको हम switch करें तो meaning different हो जाते हैं. So have to be careful about the order of quantifier. So when these nested quantifiers are true, when these are going to be false. So instead of mixing, the better word would be nested quantifiers. So nested quantifier, when they are going to be true, when they are going to be false. So if we have four possible combination of quantifiers. So for all x, for all y, p of x, y. So p of x, y, our predicate. So हम कह रहे हैं कि for all x and for all y, यानी हमारे पास दो सेट्स हैं, एक सेट x का है और एक सेट y का है. हम कोई भी एलिमेंट x से ले लें और कोई भी एलिमेंट y से ले लें, p of x ट्रू होगा. So each and every possible pair of xy, p of xy is going to be true. P of x is true for every pair xy. So ये false कब होगा? If we can find even a single pair for which p of xy is not true, then this statement is going to be false. So if there is at least one pair, अब एक से ज्यादा भी हो सकते हैं और ये सारे भी हो सकते हैं. So लेकिन अगर एक भी हमें ऐसा पेयर मिल जाए तो इस स्टेटमेंट की निगेशन हो जाएगी. So there is at least one pair such that p of x is false. और अगर इसकी हम निगेशन इस false को हम मैथमेटिकली लिखें, so it will become there is exist an x, there exists an y such that p of xy is going to be false. So our universal quantifier, when both are universal quantifier, it is negated, it is false over here. So next क्या हो सकता है कि for all x, कि आपका जो पहला सेट है उसके तमाम एलिमेंट्स के लिए आपको कोई ना कोई ऐसा y मिल जाएगा such that p of x y is true. For every x there is a y for which p of x y is true. So ये y एक भी हो सकते हैं, एक से ज्यादा भी हो सकते हैं, लेकिन x के हर एक के लिए आपको कम से कम एक y मिल जाएगा. ये false कब होगा? कि आपको y मिलते ही नहीं है. For all y it's going to be false, and even for single value of x. So there is an x for which p of xy is false for every y. कि आप एक एलिमेंट, कम से कम एक एलिमेंट आपको x में से ऐसा मिल जाए कि आपको उसके कॉरस्पॉन्डिंग y कहीं पे भी ना मिले. तो ये स्टेटमेंट आपकी फॉल्स हो जाएगी, जो कह रही है कि फॉर ऑल x there is at least one y for which p of xy is true, and we show that there is an x for which we cannot find even a single y for which p of xy is true. So for all x there exists x, for all y p of xy is not going to hold. Third case क्या है? There exists x for all y p of xy holds. कि पहले आपकी जो पहला सेट है x, उसमें एक वैल्यू ऐसी एग्जिस्ट करती है कि उसके कॉरस्पॉन्डिंग y की तमाम वैल्यूज के लिए p of xy होल्ड कर रहे हैं. ये फॉल्स कब होगा? If for all x you can find at least one y for which p of xy does not hold. For every x there is a y for which p of xy is false. For all x there is a y p of xy does not hold. So this is just opposite to this statement. और आखिरी is simple, there exists x, there exists y, p of xy means आपका predicate p of xy is true for at least one pair of xy. कि कम से कम एक x और उसके corresponding एक y ऐसा है कि p of xy होल्ड करेगा. एक से ज्यादा भी हो सकते हैं, लेकिन कम से कम एक तो है. ये फॉल्स कब होगा? जब एक भी ना हो, कोई एक पेयर भी ना हो. So for all x, for all y, p of xy is not going to hold. P of xy is false for every pair xy. For all x, for all y, p of xy does not hold. So again the thumb rule is, जब भी हम negation करते हैं quantifiers की, universal quantifier is changed into existential quantifier. Existential quantifier is changed into universal quantifier. But be careful, we have to negate the predicate. यहाँ पे p of xy है, negation में it becomes not p of xy. Let's do some examples. We can come back to, or we can just do it. So show that if we are going to have implication for all x, p of x implies Q of X, and we are going to negate this implication. So this is going to be there exists X, Q of X and not Q of X. So these are logically equivalent, these are same. So जहाँ पे देखें हम ट्रूथ टेबल तो बना नहीं सकते, we don't have P of X, Q of X, कितनी values होंगी we don't know. Although we can make truth table when P of X is hold or Q of X, लेकिन जब for all X आ जाते हैं, so again we don't know how many values of X are there. So let's do it mathematically, algebraically. So for all X, P of X implies Q of X. इसकी negation करनी है. So ये इसकी negation क्या होगी? आपकी universal quantifier is changed into existential quantifier, और जो अंदर आपकी statement है, which is an implication, P of X implies Q of X, इसकी negation हो जाएगी. Negation of P of X implies Q of X. So we know कि जो आपकी implication होती है is equivalent to not P of X or Q of X. So P of X implies Q of X is replaced by not P of X or Q of X. ये हमने last class 2 classes back हमने ये किया था. So इसकी negation करनी है, अंदर और operator है, De Morgan's law लगाएं, so it will become negation of P, which is P of X, और operator आपके n में change हो जाते हैं according to De Morgan's law, Q of X की negation. So there exists some X such that P of X and not Q of X. So for all X, P of X implies Q of X. इसकी negation is same as there exists some X such that P of X and not Q of X. Again, ये हमने पहले भी डिस्कस किया था, I repeated कि जब implication की negation होती है, so this becomes some and operator, आपकी implication गायब हो जाती है. Implication की negation में implication गायब हो जाती है. Be careful, implication की negation is not same as inverse. Inverse हमारा क्या होता है? Not P implies not Q. Negation क्या है? P and not Q. So just reminder, careful about this thing. Let's write down these statements in mathematical form. So first statement is some students in this class has visited Mexico. And second statement is every student in this class has visited either Canada or Mexico. So let's try to write it down. पहली statement है some students in this class has visited Mexico. So first of all we need to define our universal discourse. हमारा domain set क्या है? So these are students in the class. So and then they have visited Mexico. So we can write it down. The first statement, X is student in the class. So we can say M of X, X has visited Mexico. So there exists X, M of X. इसको हम एक और तरीके से भी लिख सकते हैं. Let's try to maybe express it in another way. So always remember, आपकी जो mathematical statement है, it is possible different people may write the same statement in different way, which is quite fine. Important thing is कि आपका जो message है वो same convey होना चाहिए. So let's try to write down. So X is student. हम ये नहीं कहते कि ये इस class का student है. And we say C of X. We define another predicate C of X. अब X कोई भी student है. It could be any student in our university. So C of X means X is a student in this class. X is student in this class. So we can say that M of X, the student has visited Mexico. So there exists X. There is some student X such that if he is in this class, C of X, then he has visited Mexico. So this statement means exactly the same as we define over here. वहाँ पे हमने अपना domain set जो जहाँ पे हम C of X की बात कर रहे हैं, इसको हमने already जो X define कर रहे थे उस set के अंदर ही हम ले गए थे. So उस वजह से it become like there exists X, there is some student in this class and he has visited M of X, he has visited Mexico. इसी को हम इस तरह भी लिख सकते हैं कि X is some student. So X could be any student in the university or anywhere. C of X, उन students में से वो students which are in this class, and M of X, X has visited Mexico. So there exists some X, there exists some student X. If he is in this class, then he has visited Mexico. So in plain English, जो हमारी colloquial English है, simple बातचीत की English है, उसमें हम इसको कह सकते हैं कि some student in this class has visited Mexico. Let's look at second statement. Every student in this class has visited either Canada or Mexico. So M of X, X has visited Mexico. C of X, X has visited Canada. So for all X, M of X or C of X. और अगर हम इस notation में लिखें X student, C of X student in this class, so we can write it down कि if it is C of X, C हम Canada के लिए भी use करते हैं तो हम इसको class कर लेते हैं. So class X student in this class. So if X is student in this class, so that means he has visited either Mexico or Canada. So for all X, for all students, and those students, if they are in our class, these our class students, they have either visited Mexico or Canada. Again, over here we are assuming it's simple, or अगर exclusive or लिखना हो तो we can replace or operator by exclusive or. But over here we are just assuming it's just or condition. So if a student is in this class, then he has visited Mexico or Canada. So let's look at this example. Use predicates and quantifiers to express the system specification. Every mail message larger than 1 megabyte will be compressed. So this is first statement, and then second statement, if a user is active, at least one network link will be available. तो पहले first statement को देखते हैं. The first statement. So over here, so first statement is X every mail message. So we are talking about mail messages. So we define X as mail message. और किस तरह के message? It should be greater than 1 megabyte. So then it should be compressed. So let's call C for compressed. C of X, X is compressed. So again हम इसको different तरीके से express कर सकते हैं. One expression of this could be for all X, all mail messages. For all X, compress it if X is greater than 1 megabyte. So compression का operation कौन से X पे होगा? जो भी 1 megabyte से बड़े हों उन पे you can apply compression. So for all X, compress X if it is greater than 1 megabyte. या इसी को हम इस तरह भी लिख सकते हैं कि जो 1 megabyte की कंडीशन है इसको हम अपनी क्वांटिफिकेशन में ही डिफाइन कर दें. For all X greater than 1 megabyte, तमाम वो X जो 1 megabyte से बड़े हैं उनका साइज 1 megabyte से ज्यादा है. So simply compress it. C of X. For all X greater than 1 megabyte, C of X, compress of X. So we can define, we can write mathematically, we can write one statement in mathematical notation in different way. Important thing is the message should be conveyed, the right message should be conveyed. Message आपका वही है जो आपकी simple statement में लिखा हुआ है. So आपकी different तरीके से अगर आप उसको define करते हैं mathematically, आपका message, आपका meaning change नहीं होना चाहिए. Let's look at second example. If a user is active, at least one network link will be available. If a user is active, it's implication. So we are talking about if a user is active. So if some user is active, so it means it's existential quantifier. So if there are some active users, then what should we do? At least one network link will be available. So network link, again, it's existential quantifier that there should be some network link which should be available. So we have two variables, एक यूजर का है और दूसरा नेटवर्क का है. So let's define two variables, x as user and y as network link. Y as network link. So then we have to define our predicates. So we define active of x, that x is an active user. So x is an active user. आपका user जो है वो active है. Active of x. Available of y, link y is available and link has to be available to someone, so we define available y x. So link y is available to x, available y to x. So availability of y, availability of link y is to user x. So link y is available to user x. So if we want to express our statement into mathematical notation, so if a user is active, so it means there should be some user and there should be some link, because it's at least one network link. So there exists some x, there exists some y, such that colon means such that. So active of x, if the user is active, then link y should be available. So there should be some user x who is active, then there should be some link y available to user x. So there exists x, there exists y. Active of x implies availability of y to x. This example is from Lewis Carroll's book Alice in Wonderland. I mean, it's famous novel. इस पे काफी बार movies भी बनी हैं. So these statements are from Alice in Wonderland. So these statements, I mean, it uses quantifiers in a beautiful way. So there are some statements, and from these statements we have to infer some result. We come to some conclusion. हमारे पास पहली दो statements हैं, इनको हम कहते हैं premise. And from these premises we infer something, हम एक conclusion बनाते हैं, एक result, एक नतीजा अखज़ करते हैं. पहली दो statements को देखिए, हम एक नतीजा अखज़ करते हैं. So let's see. All lines are fierce. Some lions do not drink coffee. So it means some fierce creatures do not drink coffee. We can conclude that some fierce creatures do not drink coffee. So how to express it mathematically? So we need to define. So we define x are like creatures. It could be animals, any kind of animals. So x is creatures. And we define p of x. Like x is a lion. The creature x is a lion, so we call it p of x. And then if the creature is fierce, we call q of x. And if this animal, this creature, it drinks coffee, we call r of x. So we have defined our predicates. हमारा जो input है, domain set है, it's all creatures. Again, we can define the statement in different ways. You can define with the lines. I think it's better to define with creatures, because in the conclusion we are just talking about the creatures. So x is creatures, p of x, this x is a lion, q of x, this x is a fierce creature, r of x, this animal x, it drinks coffee. Let's see. All lines are fierce. For all x, वो तमाम creatures, अगर तो वो line है तो फिर वो fierce होंगे. All lines are fierce. So for all x, if this x is lion, then it means it's a fierce creature. So p of x implies q of x. Next statement is some lions do not drink coffee. Some lions do not drink coffee. So there some की बात है तो existential quantifier आ गया. So there exist some lions. There exist some creatures which are lions and they do not drink coffee. So there exist some creatures. These creatures are lions and they do not drink coffee. Not r of x. R of x हमारा था x drinks coffee. So not r of x. It does not drink coffee. So for some creatures, p of x and not r of x. These are lions and they do not drink coffee. So some lions do not drink coffee. So from here we can conclude there exists X, Q of X and not R of X. That there are some fierce creatures who do not drink coffee. So those fierce creatures are lions. So lions do not drink coffee. So some fierce creatures do not drink coffee. This logical puzzle, maybe it's quite interesting puzzle. We can discuss it when we are doing proofs. It's very beautiful example. Maybe I can just give you overview and then you can solve by yourself. Problem क्या है? Problem इस तरह क्या है कि we have two children, a boy and a girl. They are playing in the backyard. I'm not going to solve this problem here. We will solve it maybe in some next class when we are discussing proofs. उसमें हम इसको discuss करेंगे. So, but I mean, just analyzing these statements, you should be able to give the solution to this. I mean, this is just like a logical puzzle. Given information से हम result कैसे deduce करते हैं. So a father tells his two children, a boy and a girl, who are playing in the backyard. So they should not get themselves dirty. However, while playing, both children get mud on their foreheads. I mean, both are one, and they may get mud on their forehead. So when the children stop playing, the father says, at least one of you has a muddy forehead. And then ask the children to answer yes or no to the question. So question is, do you know whether you have a muddy forehead? So father asked this question twice. पहले एक बार पूछते हैं, do you know whether you have a muddy forehead? दोनों से या तो दोनों वहाँ पे आंसर दे देंगे yes they have muddy forehead और नहीं. अगर नहीं देते, he will ask again, do you know whether you have a muddy forehead or not? And after the second question, second time, either first time or the second time, children must be able to find out कि किसका muddy forehead है. So what will be the children answer each time this question is asked, assuming that the children can see whether his or her sibling has a muddy forehead, but they cannot see his or her own forehead. They cannot touch their forehead. I mean, they are fair kids. So assume that both children are honest and that the children answer each question simultaneously. So this is the problem. कि दो बच्चे हैं वो they are playing in the garden or they get their forehead dirty or they may not get their forehead dirty. So they don't know, they cannot feel it, they cannot see it, they cannot touch it, they cannot talk to each other and tell each other. So father is asking, do you at least one of you have muddy forehead? कि कम से कम एक का तो muddy forehead है, या तो दोनों का होगा या कम से कम एक का होगा. और वो अब उनसे ये क्वेश्चन पूछते हैं कि do you know you have muddy forehead? So या तो पहली बार पूछने पे ही दोनों बच्चे आंसर दे देंगे, अगर नहीं देते तो फिर father is asking the same question again, do you know you have muddy forehead? अब second time question पे they must be able to answer the question. So can you argue कि किस तरह? So this is it's like homework to you. So maybe we can discuss it in next class. तब तक आप इसको solution सोच रखें. And there are some other examples. So exercises, actually you have to do it by yourself. Like the first example is, there are two rooms, A and B, and each room has a sign. Sign at room A says there is a lady in room A and a tiger in room B. और room B के सामने जो sign है उस पे लिखा हुआ है there is a lady in one room and a tiger in another room. So over here it's not mentioned कि कौन से room में lady है, कौन से room में tiger है. And you are given this information कि exactly one sign is true and other sign is false. Or exactly one thing, lady or tiger is in either room. So it's just like knights and knave problem. जो हमने knights and knave के problem किए, it's exactly like those problems. So we determine which rooms contain contains what. So अगर तो हम पहले को suppose करते हैं कि first is true and second is false. So first statement says there is a lady in room A and a tiger in room B. दोनों statements में से किसी एक ने true होना है because this is given condition, exactly one sign is true and other is false. So अगर तो पहली statement true हम assume करें, there is a lady in room A and a tiger in room B. So it means second statement should be false. In second statement तो exactly यही बात कह रहा है कि there is a lady in one room, it could be room A or B. So अगर room A है तो there is a lady in one room and a tiger in an other room. So अगर तो statement A is true, statement B तो उसको verify कर रहे हैं. So हम ये नहीं कह सकते अब कि एक statement ठीक है और एक statement गलत है. अगर तो statement B गलत है तो फिर statement A भी गलत हो जाएगी. So यहाँ पे ये चीजें फिट नहीं बैठ रही. So अगर statement of room A becomes false, एक में false होना है एक में true होना है, and statement of B becomes true. Statement of B क्या कह रही है? There is a lady in one room and a tiger in another room. Okay, fine, it's possible. Actually, it has to be like this. Then sign on room A is false, so there is a lady in room A and a tiger in room B. So if it is false, it means we have to consider its opposite scenario. So that should be the true one. That there is a lady in room B and a tiger in room A. So simply analyzing the statements, we can find out the solution. We can infer solution. So this you can do by yourself. So 5 friends, Abby, Heather, Kevin, Randy, Vijay, so they are online and you have to figure it out who is chatting whom. So again, it's simple logical puzzle. And then again, this is a logical puzzle. If it is Saturday today, then we play soccer or basketball. So and then we have to prove that we play basketball or volleyball. So all these statements, we express these as logical statements. So from these statements, we need to prove that we play either R or T. We play either basketball or volleyball. So try to do it if you can do this thing. Actually, इसका proof हमने जहाँ पे दिया हुआ है. So you can follow the proof steps and see if everything goes fine. And then this is another puzzle from Sherlock Holmes story, Yesterday in Scarlet. Just go through it and try to see if you can do it. So another inference example, a student in this class has not read the book. Everyone in this class passed the first exam. So we can conclude that someone who has not, someone who passed the exam, so he has not read the book. So how to express it mathematically? So let's call C of X. So X is a student in this class. R of X, the student X has read the book. P of X, student X has passed the first exam. So we can say first statement is a student in this class. So there exists some X. If he is in this class, then he has not read the book. So C of X and not R of X. So he is in this class and he has not read the book. So next is everyone in this class passed the first exam. For all X, P of X. So for all X, if X is in this class, then he has passed the final exam. So we can say that there exists some student who has passed the exam and they has not read the book. So there exists some student, they have passed the exam and they have not read the book, because we can see C of X and not R of X. They both have to be true. So C of X is true, so it means C of X is true, so P of X has to be true. क्योंकि implication में 1 implies 1, 1 implies 0 हो नहीं सकता. So 1 implies 1. So if 1 implies 1 is, so it means P of X is true. So P of X and not R of X. So there is some student, he has passed the exam and he has not read the book. So you can just write down the steps by yourself, just like over here we have shown in previous exercise. So this is your homework to do it. Actually, we have done it verbally. So let's try to do some more exercises. Uh, yeah, we still have time, so we can just quickly do some exercises. Let's see. So we are given three statements, P, Q, and R. So these propositions are: P is you get an A in the final exam, Q is you do every exercise in the book, and R is you get an A in the class. So write these propositions. The next propositions are using P, Q, and R with logical connectives. So इसमें we don't have quantifiers, it's simply logical connectives. Actually, there's similar kind of things we have done in assignment. You get an A in this class, so this is P statement, but you do not do every exercise in this book. So but is AND operator. So you do not do every exercise in this problem in this book, so not Q. So this first statement, P and not Q. Let's look at the second one. You get an A in the final. You get an A in the final, it's PR. Sorry, it's A, P. You get an A in the final P statement. You do every exercise in this book and you get an A in this class. So this is simply AND operator of all P and Q and R. So next statement is you get an A in this class. So this is R. It is necessary for you to get an A on the final. So it means if you get an A in the final, then you will get A in the class. So P implies R. Necessary means, so if you get an A in the final, then you get an A in the class. So you get an A in the final, but you don't do every exercise in this class. Nevertheless, you get an A in this class. So nevertheless is again same as AND operator. So this is, you get an A in the final, so it's P, but you don't do every exercise in this class, so it's not Q. Nevertheless, you get an A in this class, so it's AND R. So P and not Q and R. Let's look at E. Getting an A on the final and doing every exercise in this book is sufficient for getting an A in the class. So it means if you get if you want to get this result, that you should get an A in this class, so you should satisfy these two conditions. So P and Q, getting an A in the final and doing every exercise in this book, P and Q. So this implies you get an A in the class. So this implies R. P and Q implies R. The last one, you will get an A in this class if and only if. If and only if, so it's by condition. So you will get an A in this class, P, if and only if you either do every exercise in the book or you get an A in the final. So R, you get an A in this class, this is R. So R, if and only if, either you do P or you do Q. Either you do get an A in the final exam or you do every exercise in the book. So these are just mathematical notation of our English statements. So here is another example for quantifiers. So suppose we are given these three statements. No doctors are enthusiastic. You are enthusiastic, and we conclude from here, therefore you are not a doctor, because no doctors are enthusiastic, and you are enthusiastic, so it means you are not a doctor. So suppose X is a person, and D of X means X is a doctor, and E of X means X is enthusiastic. So let's express above statements mathematically. So for all X, if X is a doctor, then he is not enthusiastic. E of X implies not E of X. If someone is enthusiastic, if someone is doctor, then he is not enthusiastic. But you are enthusiastic, so E of, let's call it U. So you are enthusiastic. So this implies you are not a doctor. Negation of D of U. D of U, you are a doctor, and it's negation, so you are not a doctor. Okay, we can maybe do a couple of more exercises and then we can conclude our lecture. So we are given some mathematical statements. We need to write down these statements in English. So first statement is for all x, there is a y such that x is less than y. जबकि हमारे पास x और y real numbers हैं. So for all x, there exists a y such that x is less than y. हमारे पास जितने भी real numbers हैं, we can find a number which is greater than these x numbers. So इसको हम इंग्लिश में डिफरेंट तरीकों से रिप्रेजेंट कर सकते हैं. So one way of writing this could be, for all x there exists a y. I write it down like this. So for all real numbers there is, and this is not a good statement, but I'm just writing for the time being like this. For all real numbers, for all x, there is a real number which is greater than these numbers. This statement conveys the message, but it doesn't look so beautiful. We can express it in more beautiful. So it's not a beautiful statement. जब हम आम जिंदगी में बात करते हैं तो हम इस तरह की बात नहीं कर रहे होते. We say things in different ways. So let's write it down that there are infinite real numbers. हमारे पास infinite real numbers हैं कि हमारे पास जितने भी real numbers हैं, we can always find a number which is greater than this number. और अगर हम इसको, वो भी एक real number होगा, अगर हम इसको भी हम अपने real number के set में डाल लें, again we can find another number which is greater than. For all x there is a number such that this number is greater than all these real numbers. All real numbers, जितने भी हमारे पास real number है, we can still find another real number which is greater than all real numbers. It means all real numbers, they will never finish. They are going to be infinite. So there are infinite real numbers. So this looks more, how to say, beautiful statement. So let's write next one. So next statement says, for all x, for all y, तमाम real numbers के लिए, if x is positive and y is positive, so their product is positive. So this is simple. For all real numbers, the product is product of positive. Actually, we can write it on. For all हमें explicitly mention करने की ज़रूरत नहीं है. We can just say कि product of positive real numbers is positive. Positive real numbers is positive. चलें 2 की बात हो रही है, so we can write it down that product of 2 positive real numbers is positive. Although it doesn't matter कि 2 number हैं या 2 से ज़्यादा हैं, so product will always remain positive. So product of 2 real positive numbers, 2 positive real numbers is positive. So for all x, for all y, x is it's actually non-negative because it's greater than equal to 0. So instead of positive we should mention, क्योंकि 0 भी इसमें आ रहा है, so we should say non-negative. 2 non-negative. So always remember the difference between positive and non-negative. Non-negative के अंदर 0 भी आ जाता है. Positive में 0 नहीं आएगा. 0 is a neutral number. So product of 2 non-negative real numbers is non-negative. क्योंकि अगर 0 से multiply करेंगे, so it's going to be 0. So we should write down non-negative. So now this statement is perfect. So product of two x and y, two non-negative real numbers, is non-negative. So the last one is for all x, for all y, there exists c such that xy is z. So it means आप कोई से भी दो real number लें, उनको आपस में multiply करें, we will get another real number. So अगर तो हम इसको simple I mean again not a beautiful statement में लिखें, so we can say कि for all real numbers their product is a real. For all real numbers की जगह हम कहते हैं कि for any two real numbers, दो numbers की बात हो रही है, for any two real numbers their product is a real number. That's fine actually, but if we want to write it in a more beautiful way, more beautiful way. So in a more beautiful way, how can we say? I mean, it's a property of real numbers that whenever we have two real numbers, we are going to make their product. So obviously, the product is going to be real number. So we can express it as real numbers are closed with respect to multiplication. So it's a closure property of real numbers. Whenever we will multiply real numbers with each other, we will get a real number. So real numbers are closed with respect to multiplication. So अगर statement इस तरह के दिया हो कि real numbers are closed with respect to multiplication, how to express it mathematically? So this is the way to express it mathematically. For all x, for all y, there is some z such that xy is equal to z. कि आप कोई सा भी pair of real numbers लें, उनको multiply करें, so you will get another real number. So this is closure property of real numbers. That's fine. We are almost finished with the time, so I should say express these statements in mathematical form. Maybe we can do one or two and rest you can do by yourself. So let's f of xy be the statement x can fool y. So where the domain consists of all people in the world. So use quantifiers to express each of these statements. Everybody can fool Fred. Everybody. So for all x, we have x of y. So f of x y. So x fools y. This is our predicate, that x fools y. So everybody can fool y. So everybody x fool y. So x is everybody. So for all x, such that everybody can fool y. So instead of y, we just read Fred. So everybody can fool Fred, like this. So for all x, f of x and Fred. So it becomes like this. Next statement we can express Evelyn can fool everybody. Now the first person x is Evelyn, and Evelyn can fool everybody. So we write down for all x, now for all y, because everybody is going to get fooled by Evelyn. So Evelyn can fool everybody. So this is going to be y. So everybody can be fooled by Evelyn. So everybody can fool somebody. I think I will do this and I will stop, and then you. Oh, okay, we can do two more, and then you can do rest by yourself. Everybody can fool everybody. I can fool somebody. So who is going to fool is everybody, and who is getting fooled is somebody. So for all x is going to make fool. For all x, there exists some y such that f makes, so f of xy. So for all, there is someone who is get fooled by x. So everybody can fool somebody. Part D, there is no one who can fool everybody. There is no one who can fool everybody. So this is like a negation. There is no one, not a single person. So who can fool everybody? So this will become for all x, for all x, if there is no one who can fool everybody. So अगर तो हर कोई किसी को फूल बना सके तो उसकी नेगेशन क्या होगी कि there is someone who can fool everybody. So there is no one who can fool everybody. So for all x, there is not even a single person. So for all x, who can fool everybody? So for all y, so we cannot fool everybody, cannot fool everybody. So f of xy. So it will be something like this. There is no one, not even single one, for all x, so they cannot fool everybody. There's no one who can fool everybody, so negation of making fool ho jayega. So everyone can be fooled by somebody, so it means somebody can fool everybody. So no one can fool both Fred and Jerry, so Fred and Jerry isme aa jayega. So no one, for all x, they cannot fool, not f of x. Nancy can fool exactly two people. So this should be interesting. So let me do this. E you can do by yourself. F you can do by yourself. Let's look at G. Nancy can fool exactly two people. So we can express it in different ways. Exactly two people. So there are some people. So there exists some y such that they get fooled by Nancy. So Nancy can fool y, and we have to be more specific, and the size of y is, and size of y is exactly equal to 2, and size of y is equal to 2. So this and we can put it inside or we can put it outside. Okay, exactly दो लोग हैं, the y हैं, there are two y. So Nancy can make them fool just like this. So I will stop my lecture here.